So just keep that in mind. All right, and we're going to do one more here, and then I think you'll be able to do most of these worksheets. So besides looking at some word problems, that'll pretty much be it. So I want to do number 4 specifically because it has a fraction in it, okay? So you want to give it a try on your own. They gave us some tables, some values already in our table, 0, 2, and 4. So you solve for y, put your point. Okay, sorry, lost connection, but it's like you're back. So back to what we were talking about. We're working on this problem. Solve for y, put it on the graph, see if you can find the x, y intercept and the slope, okay? And then come back and watch me go through it. All right, so I'm back. We'll see how you did with these fractions. The reason I wanted to pick the fractions is because I wanted to tell you that at least right now when you're solving these linear equations, if you ever have a fraction here, the best way to deal with the fraction as far as picking which values for x is you want to look at this bottom number of the fraction and you want to put multiples of that, okay? So 0 is good, 4 is good. I maybe wouldn't have picked 2, I might have picked 8. But multiples of 4 is a way to kind of get rid of that fraction, and you're going to see what I mean by that. But they picked these numbers for us, so we're going to go ahead and work through what they have. But I made my grid, and so now we're just going to kind of work through each of these separately, okay? So as I said, the best number to start with is always 0, because it doesn't matter if you're multiplying a fraction or not. Anything times 0 is 0. So if I put a 0 in for x, 3/4 times 0 is 0 minus 1. 0 minus 1 is -1. All right, now I'm going to work this one out on paper. 3/4 times x, which we're saying is 2 minus 1. Now when we multiply fractions times whole numbers, our first step is really put that whole number into a fraction form by putting it over 1. Okay, so now we're doing 3 over 2, or 3 times 2 over 4 times 1. And best way to do that is cancel. So the 2, this is why we're picking multiples of 4, because it's going to cancel this top and bottom out. So 2 goes into both of these numbers. 2 goes into 2 once and 4 twice. And so we're left with 3 times 1 is 3. Over 2 times 1 is 2. 3 over 2 minus 1. Now this is exactly why I said I would not have picked 2, because 2 is going to, we're still dealing with the fraction. You're going to see when we pick 4, we have a whole number. And if we would have picked 8, we would have a whole number. We wouldn't have to deal with this right here. But regardless, we had to do what they gave us. So 3 halves minus 1. When we're going to subtract, we have to have common denominators. And so I'm going to start by making that 1 into a fraction, 1 over 1. And I need to raise 1 over 1 up to where it has 2 as a denominator, which really means 2 over 2. 2 over 2 is still 1, but now I can actually subtract these. So 3 halves minus 2 halves equals 1 half. Yet another reason they probably should not have picked 2 for x, because now we're left trying to find where 1 half is on the y. Not a good deal, okay? So I'm actually going to add a 4th point on here with 8, so we can get an accurate line. All right, erase that. Let's see what happens when we multiply it by 4. 3/4 times 4, which is 4 over 1, minus 1. So notice what happens here is our 4's actually cancel each other out completely, and we're left with 3 over 1 over 1 times 1. 3 times 1 over 1 times 1. Okay, sorry, lost connection again. So we were multiplying 3/4 times 4. They canceled. We get 3 over 1, which is actually 3. When I work that out, I get 3. Bring the second part in, which is -1, to give me 2. All right. As I said, I'm going to add a third point because I don't want to try and locate this one, 2 and 1/2. So I'm going to add a fourth x, which is 8. So we're going to multiply that times 3/4. So put your 8 over 1. Your 8 and your 4s cancel, but this 8 turns into a 2. So now we have 3 times 2 is 6 over 1, which equals 6. Subtract the 1. So we get the point 8, 5. Now maybe 8's not, maybe 8's too big for this graph, I'm not sure. But it does at least give us another point. You can see how that results in whole numbers. Okay, so put these points on the graph and then go ahead and draw your line and come back. Okay, so drew our line. Should look something like this. Here's our 3 points. Fourth one, if you could fit it on your graph, I actually couldn't fit it on mine. So 0, -1, over 2, up 1/2, over 4, up 2, creates this general line, okay? So the x-intercept, where does it cross the x? Let's see, what is this? So here's the problem with the worksheet. It doesn't cross on the x. Let's look at the actual sheet. Doesn't cross right at a whole number here for the x-intercept. So in a way, this was a bad problem for the worksheet, okay? But we can still use our other points to make our line for sure. And the y-intercept definitely does cross at a specific point, which is here, okay? So we're gonna not put an x-intercept, but the y-intercept is where the line crosses the y, which is at 0, -1. And then go ahead and try and find the slope, whether from the table or the graph. And to do that, we're going to go from one point to the other, start with a rise and then a run. So it looks like this goes up 1.5, not great. And then over 2. So this is wrong on all sorts of levels here. Okay, so 1.5 over 2. You can't have 1.5 as part of a fraction. So we're going to change, we're going to go ahead and raise this to where this would be a whole number. Okay, so we're going to double each of these. 1.5 doubled is 3, and 2 doubled is 4. So to have whole numbers in our slope, our smallest whole numbers would be 3 over 4, which you actually can't see on there. There you go. 3 over 4. Tough problem. That's part of the reason I wanted to go through that one with you. And actually, let's look at, maybe this would be one where finding the slope from the points themselves would be easier than from the graph. Okay, so let's pick 2 points. I'm going to pick these last two, 4, 2, and 8, 5. y2 minus y1 over x2 minus x1. 5 minus 2 is 3. 8 minus 4 is 4. It's already simplified. They're both positive, so we end up with a positive 3/4 for a slope. All right, I need to wrap this thing up. So, should be able to do these pages. I've sent, I think, 3 function table sheets where you're just solving, okay? Plug, substitute the number in for x and solve for y. Do that multiple times. That's good practice. This actually gives you quite a few problems here, including some graphs. Go ahead and give those a try. This is a single sheet of function tables, answers on the second page. You can check your work. Same for this one. I'm including this worksheet, which just gives you the equation. So you're going to have to come up with your own table and solve for some coordinates. Okay, so that one's going to be a little bit more challenging. I think you can do it. Remember, on these fractions, choose numbers for x that the denominator of the fraction will go into. Okay, and then there's some lines or the answers that show what lines you should be coming up with. Then the last one is these word problems.